Okay, I'm back. I'm going to do the second part of the 1.2 handouts that I gave you guys in class before we left. It has to do with, let me show you what I'm looking at here. It has to do with finding the turning points. Sometimes those are also called maximums and minimums. And then being able to get a good window to do that. So this would be the example of a maximum. Just means for that local area, it's a local max or relative max. If you have something that's coming in and turning around, if it hits a low point and then comes back up, that would be a local or relative minimum. So we're looking for basically these turnaround points. Okay, so while I have this one on here, because I probably won't come back to this, everybody. There it is. Let's go back. Let's put this function into our calculators, or let's write this down and I'll show you how we're going to do it. I'll start again with the TI-84. So we're going to put that in our calculators, negative 5x squared minus 20x plus 1320. And it says we'll start in the standard window. So let's try that. So if you don't have this sheet, hit pause and copy that down, negative 5x squared minus 20x plus 1,320. And then unpause it and come back and let's all get it graphed. So I'm going to switch over now to the graphing calculator window here. Back to the main screen, just kind of get rid of everything. Okay, so let's put it in there. It says, I'm using the calculator now. So it has f of x equals negative 5x squared minus 20x plus 1,320. There's a function in there from the other video, or I'm just going to hit clear to get rid of the old one. Now, on the calculators, we already have the first part of the equation, right? It says y1 equals. So all I need to do is type the expression in x that comes after the equals. So negative 5x squared. The negative sign is important. Make sure you go below the 3. That's your negative symbol down here. So negative 5x squared. Subtract. Now the subtraction is on the side underneath the times button, minus like that, 20x, and then plus 1,320, 1,320. So there we see how the negative in front of the 5 is a different symbol than the subtraction sign in front of the 20. The calculator makes a distinction here. Desmos will not make a distinction. Okay, so there it is. It said graph it in the standard window. We learned on the other video how to do that. If you hit zoom, it's a really fast way to do it. You just go down and select number 6, or just type the number 6. It will expand the window, and then it will show you what part of the graph is visible in that window. So we've been sitting here talking for a minute and nothing ever showed up. So what that tells us is the graph does not live between negative 10 to 10 on the X and Y axis. It's not right in the middle near the origin. This graph is somewhere else. Okay, so it gave us some suggestions on this one, but so we don't have to just goof around with it. But, you know, if we were on Desmos, we could just keep hitting the zoom out button and we'd probably find it eventually. So we might do that when we get over to Desmos. But for right now, it's giving us some suggestions on the problem. It says we're going to change the window. So this is sometimes what it does in the homework. It gives you a window setting to use. So it says, let's change the window. And it says X min -8, X max 4. So again, I'll do the negative down here. You don't have to clear these values on the window. You just start typing. So -8 to +4. Go down and hit +4. They didn't give us anything about the scale. So I just scoot past that one and go to Y min and Y max. This is Y min 1,100. 1,100. And Y max is 1,400. That's 400. So this graph was way, way up there in the 11 and 12 and 1300 Y values. That's why we couldn't see it just looking up to Y equals 10. All right, so that's the new window that we were asked to use. Now we're just going to hit the graph key and see what it looks like. Should have a turning point. There it is. So it's something that increased for a while, hit this high part, the maximum, that turning point when it's like a downward shaped bowl, then the top is the maximum, and then it goes back down again. So we would like to know what the coordinates for that turning point is, that highest place. Okay, so trace won't be good enough, although I noticed it did start right on there. But if I do the trace, I'm watching my Y values down here and it says 1340, 1339, 1340. So maybe it's this one in the middle. But I'm telling you, usually when you do a graph, the point you're looking for isn't nice and pretty and neat like that. We have to kind of find it. So anyway, let me show you, if you're just moving around on the graph, there is a feature in the calculators that's kind of programmed in there that will let you find that maximum turning point. So over the trace key, there is something that says calc, and there's a bunch of different kinds of calculations on a graph that the calculators are able to do. So I'm going to hit the blue second and then trace, which is really the calculations. And we use these all the time in our algebra and calculus classes. So right now, 3 and 4, you know, we were talking about minimums and maximums, where it's going to be one of these when you want to find a turning point. Now, the one we're looking at, it comes up, it peaks at a maximum and then comes back down. So we would like to know where that turning point is. So that one, because it's at the top of a hill, that turning point would be a maximum. So we're going to go through this and it's going to start asking us a couple of questions. It wants to know where on the graph to look. So when you do a maximum request on the calculator, it starts asking you questions at the bottom. It says left bound with a question mark. All that means is it wants you to use your left and right arrows to move the cursor to a spot on the graph that is to the left of that maximum point that you're looking for. Mine actually is already there, but anywhere up, it doesn't have to be an exact science, but just anywhere on this uphill part is good. So I'm going to hit enter to nail it down. So the calculator, when it says left bound or right bound, it wants you to use your cursor to move use your arrows to move the cursor to the left of the point, and then you hit enter to fix it to where it doesn't move around. Then the question down here, as soon as I fixed the left hand, see it has an arrow that's pointing that way. So it means we're going to look from this point to the right. And then the right bound is the same thing. It wants us to move the cursor until we are to the right of that high point that we're interested in. So I'm just going to hit my right arrow till I'm just going to hold it down and we're just going to sail across it. Now I'm on the downhill side over here somewhere. That's the y-axis I'm heading towards there. But I'm on the downhill side here. I could go all the way down, way out here. It doesn't matter. All of these are fine. It's anything that is to the right of that high point that we're looking for. So I'm going to hit enter again. Then it asks us for a guess. Most of the times you can just skip this and hit enter, but the guess is just in case between the two places that you've marked, there's 2 of these points occurring that you're interested in. Like it's a different problem, but if I was looking for x-intercepts and I put the minimum over here and the maximum over here, and this graph had 2 x-intercepts as it passed through it in 2 different places, the guess would mean move your cursor closer to the one you want me to find first. But in this case, there's only one maximum, so it doesn't really matter what you do with the cursor. I'll go ahead and slide it close to that. Anyway, hit enter is my point. So we're going to hit enter. It thinks for a second, then it spits out the coordinates for that point as accurately as it can. In this case, it's totally accurate because it doesn't have any decimals. So that means that's exact. So when x is at -2, the maximum y value or the maximum function value is 1,340. So we call that point a local maximum, or we call it a relative maximum, because it means in that local area or relative to the points around it, it's the highest. It doesn't have anything to say about maybe it dips down and then scoots way up higher later on. We just mean in this little area, that turning point represents a maximum for that little section of the graph. Okay, and if it asks you for a maximum value, we mean maximum function value, and that would be the y, 1340. If it's asking for an ordered pair, then we report both numbers as an ordered pair. Okay, so that's just to say. All right, so that's what we will want to do if we want to find a turning point. We run that max feature or the min feature. They're both over the trace key. Let me show you where those are again. I'm hitting the blue second function trace. And then if it's something that peaks and then falls, so it's at the top of the hill, that's a maximum. But if it's something that drops, hits a low, and then goes back up, then we would select minimum and then see those same questions about left bound, right bound, and narrow it down, and then it'll show you the coordinates for that point where it's turning around. Okay, so if I'm looking at this sheet, it says, is the turning point a relative maximum or a minimum? We kind of talked about that. Since it peaks and then falls, it's a maximum. And then we found the turning point, that was part 3. And so I guess we've already done it. So let's just run through it real quick in Desmos, and then that'll be all that we're gonna do with this. So let me stop sharing this. Let me go back to Desmos and we'll call that same thing up, because again, Desmos, I wasn't a big fan of Desmos. I was telling somebody the other day because I've just been using the calculators for so long, but honestly, it's pretty nice. So I'm just gonna close all those lines of codes we had typed in before. So this time I'm gonna type in that same negative 5x squared minus 20x plus 1,320. It's written as a function, so I'll go ahead and use the function notation. Remember in Desmos, you have to type the entire equation, not just the part after the equal sign. All right, so negative 5x squared, negative 5x. Notice as soon as you type it, it starts trying to graph what you're typing as you type it, but I need to square that. So I'm going to open up my little keypad down here. And at the top where it says a squared, I can use that. If I needed a different kind of exponent, that's what the a to the b power is. So there's negative 5x squared, and then subtract 20x, so minus 20x. And then plus 320, plus is over the equal sign up here. I guess I could use it down here too, right? I was using my keyboard, but you could, my actual laptop keyboard, but you could also use what's showing on the screen here. So plus 1320, I'll go ahead and use this stuff. Yikes. All right, so you can see again that it's such a function that has such high y values that we just don't see it anymore on this particular graph. Let me close down the rest of that. Okay, so remember before we went and typed in the different kinds of window settings, and it gave us like the, what was it, -8 to 4, and then 1100 to 1400 down here, so we could type it like that. I'll do that in a minute, but I also want to just show you, let's just zoom out. How far out will we have to zoom? Okay, we can start to see the sides of it, so we could slide it down, and after a while we're like, goodness, it's taken a long time, so let's keep zooming out. Zoom out, zoom out, zoom out. Well, now it's getting so, you know what I'm saying? When I zoomed out this way, every time I zoom out vertically, it zooms out horizontally, but makes the sides look closer together. So this is probably one where it would be better. Now that I've got it in the middle of my screen, I'm gonna zoom it back in. There I go. And see, I'm starting to get into these numbers that it was asked in on the graphing calculator. It said go between 1100, which is down here. Let me zoom out one more. So between 1100 and 1400 up here was the graph, but it was a lot fatter on our screen. That's because we only had our x values going from, you know, -4 to 8. Is that what it was? Or -8 to 4, or this is going out in a couple hundreds. So it is the same function, but because the window settings are so different, it looks different. All right, so I am going to go ahead and get to the graph settings and pull in the sides of my graph, because I have the sides of the graph so wide that the function is just living right in the middle of this giant wide window, and so it's hard to see. They're very close together. So I'm going to go back and do what it said to do on the little sheet, which is to just bring it all in. Let x go from -8, is that -8, and then to +4. +4. Okay, and then the y min was 1100 and something. I'll leave that one. The y max was like 1400. I'll go ahead and put that back in. So you can play around with the window settings, zoom in, zoom out, hold your cursor down and then, or hold the clicker down and then just move it around. You can slide it around, or you can actually just type in some left, right, up and down numbers. Okay, so this looks a lot like it did on our calculator. This is the nice part. If you just click on the graph, maybe you have to get closer and click on the graph. I clicked on what I thought was about the top of the graph, and see, that is the same exact point that we had to do that max thing with the left bound, right bound. The Desmos people, when they wrote this, they understood that we're probably interested in these turning points and then the x and y intercepts. So they went ahead and have something calculating that maximum for us. So there it is, and look over here. Also, there's our y-intercept. That's another one that it's graphed. I'm sure if I went way, way, way back down to the x-axis, let me do this and go fast here. So I'll say, let's say my y. If I want to get back to my x-axis, I need to make y negative. Just do Negative 200, something like that. Oh, now I gotta go way over here to see. So there's the x-intercept. If I click on it, there's the x-intercept. So the rest of them, you'd have to hold the cursor down to get estimates for the other points. But if you want to know where any of the intercepts are, if you can get the intercept on this screen, just click on it and it will give you a good decimal estimate. I shouldn't say it's not great. 3 decimal places isn't all that good, but it's so much faster. So it's pretty nice. There's our y-intercept again, was it 0, 1320. And then right next to it right there, there's my maximum. You could, on this window, it's hard to see that that's the highest point that it is. Okay, so my whole point about Desmos was to show you how to enter a function in. You have to type the entire equation, either y equals or f of x equals. I recommend f of x equals like this so that you can plug in different points easily and calculate them. And then as far as the window settings go, the little tool at the top will allow you to physically type in your min and max. It has a zoom square on it. No, I didn't like that. Let me take that one off. Can I do that and get rid of that? I guess I have to just physically reset these again. Yeah, anyway, you can do all kinds of settings if you want to on this. I'll go back to the -4 to 4, -5 and 5. Yeah, it just bugs me. This makes no difference. I shouldn't care. Yeah, anyway, I don't know if that's any better. Okay, so entering the function, make sure it's the entire expression. You can adjust the window with the little tool, or you can just literally zoom in and zoom out until you can see the part of the graph you're interested in. So there it is again from a different perspective. If I click on it, it's going to show me, here's my x-intercept. Up here is my peak, that's my maximum. The one that's right next to it that's a little bit lower is the y-intercept, and then way over here is the x-intercept. So there we can see all 4 things just like that. So Desmos is pretty quick and it's cool. Now I'm just going to hold my cursor down. I can move it around. So it's a lot quicker to use, but the symbols, you have to get used to how to type those in. Okay, so that's all it wants to do is to find the turning point. We found the turning point on using both methods. So that's enough. Sorry it took so long, and hopefully it will help you on your homework. Okay, see you all Monday.